Hello, everyone, and welcome to our webinar today entitled How We Measured Discharge and Water Quality on the Mississippi Autonomously. Let me first start with introducing our speakers today. First, we'll have Evan Lay, who's the lead product and sales engineer at SURF B. We'll also have Sean Snedden, who is a systems engineer at YSI at Xylem. And then we have myself, Shua Fan. I'm an application engineer at Sontech, also at Xylem. Just a quick overview on our agenda today. So we've gone through the introductions. I'll be covering a little bit of an overview just to set the stage on the Mississippi River and why we care about measuring discharge and water quality on the Mississippi. And then Evan will go over the SURF B platform, some SURF B history, as well as the boat features. It'll come back to me. I'll be talking about the M9 measurement itself, the data and the challenges we faced in this measurement in particular. And then Sean will talk about the YSI ExoSonde data, that water quality data, and then we'll go over some conclusions. So before we get going, we wanted to launch a quick poll. So if you in the audience wouldn't mind interacting with this poll, what is your ADCP or water quality data collection experience? So please fill out the answer that best represents you. We'll give it a couple seconds for all the answers to trickle in here. So this gives us a better gauge of you as the audience. It looks like we have quite a wide variety of experience here, some beginners, some intermediate, and maybe some very experienced ADCP and water quality users. So a great spectrum across the board here. Thank you for that. All right, so moving on to the content of the webinar, let's go over an overview of the Mississippi region. So for those of you who aren't familiar, the Mississippi River is often known as the backbone of America. It's the second longest river in the US, spanning about 2,341 miles. It's a vital artery for commerce, agriculture, and communities, spanning multiple states, and is one of the world's largest watersheds. And interestingly, it ships about 60% of the US grain and serves 20 million people with drinking water. So as you can probably imagine, measuring the river's discharge has been a crucial endeavor for over a century, enabling flood forecasting, navigation safety, water resource management, and ecological studies, to name a few items. So let's talk about gauging on the Mississippi. The USGS, so the United States Geological Survey in particular, has been collecting discharge data on the Mississippi since the late 1800s. And the USGS has been faced with formidable challenges. So for example, in the 19th and the 20th centuries, discharge measurements were made using rather rudimentary methods, including manually operated mechanical flow meters, floats, and fairly rough river stage and cross-sectional area relationships to obtain the discharge. So in the Mississippi in particular, the vast width, shifting channels, strong currents, and sediment loads present pretty large challenges, especially for gauging or discharge measurements in particular. Just one quick example, in 1927, there was a great Mississippi flood, and the gauging stations really struggled to provide timely data amid this catastrophic flooding. So it really just underscores the necessity and need to have good infrastructure and good gauging along the Mississippi. And today, the USGS operates about 37 gauging stations along the Mississippi. And with the advancements in ADCP technology, we've been able to greatly improve the ease and the accuracy of discharge data. However, the river's complexity still makes gauging quite difficult, even with ADCPs. So here at Sontech, not only do we develop acoustic instruments or ADCPs to measure river discharge, we also partner with new technology in order to provide more ease and more accuracy in your discharge measurements. So today's webinar will focus on our partnership with the SURF B boat. And with that, we will pass it on to Evan, who will talk about the SURF B in particular.
Thank you, Shua. I'm going to start into it. I'm just going to start introducing myself. My name's Evan Lay, as Shua said, and with a little bit of background about SURF B and who we are and where we're from. So we're based out of Australia, in a little town called Albury, which is roughly 3 hours drive north of Melbourne, and you'll see in the red circle there where that is. We were established roughly 6 years ago. We have 6 full-time employees and 2 part-time, and at this stage we've built roughly over 300 vessels so far. Who I am, I'm the lead product and sales engineer. I started a little bit of background on myself. I started working in the family engineering business and moved into structural and civil engineering, and then got a position at Water New South Wales, which is a large water provider in Australia, and worked there for 7 years, mainly using Sontec and YSI equipment and a lot of the other major suppliers of USVs at the time. And I was constantly sort of innovating in the background, working on USVs in my own time, and then started at SURF B to help develop the Flow series USVs for ADCP specific deployments, and been doing that for the past 6 years. What makes SURF B different for ADCP deployment? The first one is specificity. Our vessels were designed specifically to do ADCP measurements. They weren't survey vessels first that then turned out to do some ADCPs and flow measurements. So that just, we really cater for the particular instrument, and the boat behavior is developed around that. Reliability. We have a lot of features that really matter when you deploy a vessel. So like redundant steering system, so you can get all your gear and your vessel back if you fall into problems in such a dynamic environment, such as a river. We have specific mission planning and automation wrapped around this ADCP deployment. And efficiency. Our equipment is very streamlined and integrated with the sensor. We have common power tool batteries that are fitted inside there, so that makes it easy for procurement and keep your boat running and out on the water doing measurements. This is a start of the Flow series platform, and we have multiple boats. We have 4 in total in the range. We have 2 specifically for low flow measurements, which is the Flow Scout and the Flow Finder. It is very difficult to do low flow measurements. If anyone that's done a lot of measurements would know that. So we have some boats specifically designed around that to capture those. And then we have the Seeker and the Duet, which I'll show the Duet shortly. And these are designed to do the faster flows and bigger rivers. So this is 4 meters a second top speed. They all have the generic electronics across the range in terms of the autopilots, and then we wrap the hulls and different dimensions around the specific needs. The boat that was used for the Mississippi measurement was the Flow Duet, which is what you can see in front, and it is a very versatile platform. It's designed around taking 2 sensors at the same time, so this could be a combination of a lot of things, an ADCP and a water quality sonde such as the XO. It could also be a single beam echo sounder, and in the future we'll have a profiling winch and a water sampler wrapped around it. It is a bigger platform that allows us to be able to deploy bigger payloads or multiple payloads at once. And just going around the vessel, where our biggest features that we have is dual GNSS heading system. So we have the ability this gives the boat the ability to operate in conditions where it has a lot of magnetic interference, such as the Mississippi, with big sheet piling, bridges, and large metal vessels. And it gives it much more reliability in these conditions. All our vessels have a live camera feed back to the bank that comes onto the controller, which we'll see the controller in a minute. And it's great for these long cross sections like the Mississippi, where you need extra sensors to help you navigate through these. In the photo there, it's got the Somtech M9 on there, and it's got the spot for the EXO to fit into the back. So the EXOs and the M9's in the front. We have a redundant steering system that you can't quite see in this photo, but it's in the back center there. So this gives you this backup steering system if you foul a motor at the front. The electronics is the same as we stated before, and all our hulls are an inflatable hull, so they can pack down small and be rolled up, and we air freight all our vessels around the world. The transmitter, this is a big part of the problem. This is the sort of the interface with the boat that the user uses. So this has to be very reliable and has all the information that you need to get a great gauging. So it's an Android-based system. It has a long range, 750 meters is very typical for this. It is ruggedized to a certain extent to help you, withstand dust and all the usual sort of outdoor sort of activities. USB-C chargeable, does the HD video transmission that you will be able to see on the screen. And we can also put end-trip corrections through this if you hotspot to your phone and get it on the internet. So it allows you to do all the things that a phone can do as well. The SURF B app. SURF B app is, I always say, it's about 33% of the problem. It's something that really needs to be a very nice user interface, because if for an autonomous vessel, you need to be able to make it do the autonomy, and this is the interface for that. The key features of this one, it has specific places for ADCP mission planning. You can do bathymetry planning on it as well, and water quality. This is all standard. This is not a separate add-ons or anything. This all comes standard with the boat. RTK corrections in. You get all your vessel diagnostics, battery levels, and the state of the arming and what modes it in. We have Android and Windows versions. We can also import HYPACK waypoint missions in there and run them on our controller, which is a very useful thing if people have HYPACK. And the camera integration is not in the app, the SURF B app at the moment, but we're working on that at the moment to make that system better. It is a separate app at this stage. Now, what allowed such a large measurement on the Mississippi with the SURF B is the ADCP specific part of the app, our SURF B app. And this allows the person to be able to set the left and right banks for your gauging. Generally speaking, on smaller rivers, you can actually drive to that location and then set the left bank and the right bank, and then you can then press go and the boat will autonomously navigate between those 2 points. In this case, we actually set the near bank with the boat location, but the far bank, we actually dragged out that waypoint because it's such a wide section. You don't have many bites of the cherry to be able to get that to drive the boat across. So we actually manually set on the screen using the background map as a guide the far bank location, and that really speeds up that mission planning on sections that are extensively wide. So we have moving boat and stationary method in the app, and you can swap easily between and set your station distances apart. So this is really speeding up that deployment and making it super repeatable for ADCP measurements. Some accessories we have on the boat. We have what we call the flow sled, which is an attachment to the boat that you can buy if you have specific sites that have very rugged conditions, or you have a lot of slope in your area where you have a lot of fast water for flooding. So this allows you to have a bigger boat when required, but then don't have the inconvenience of carting around a bigger boat for the entire time you own the vessel. So it is an add-on that has been very well received for people that can that need that requirement. So one of the photos is in New Zealand where they have very flashy catchments and can get a lot of water coming down quickly, and it just increases the reliability of the measurement. And accessories and mounts. So we have a large variety of mounts that we can put in for different ADCPs. In the picture here, you'll see the M9 with our splitter cable attachment. So we can actually take the GNSS from the autopilot and actually run it back into the ADCP. So this makes there's a tighter integration with the ADCP, and also you have the added benefit of being then able to put the GNSS heading into the ADCP, which makes also the ADCP much more immune to magnetic interference and have a reliable heading, external heading source if your bottom track is no good. So you'll see down on the bottom there with the RS5, that is a picture of the multiport. That's where the GPS has been outputted to the RS5 from the SURF B pod. Which is a great innovation for minimizing deployment and the weight of the vessel, taking that external GNSS off. And thank you. Back to Shua.
All right, thanks, Evan. So let's take a closer look at the actual ADCP measurement on the Mississippi. All right, so on the left here, I am showing a map view of the actual transect. And so you can see that in this blue and purplish line going across the Mississippi here. And downtown New Orleans is to the left right here. And on this right side, I'm showing the SURF B Duet, as Evan mentioned. This is the system that we used to transect the Mississippi that day. And so going from the top to the bottom, again, we have that GPS or GNSS mast, which includes the locations as well as the GNSS heading. There's the dual antenna system there for the heading. And then below that, we have the M9. I know it's very small. The M9 ADCP there. Below that is the PCM, the Power and Communications Module. For those of you familiar with the M9 system, you'll notice that this M9 does not have the standard GPS antenna that comes with the M9. And the reason is because we actually have the cable going from the M9 directly into the SURF B pod here. And so all that GPS data are being routed into the M9 and being processed. So that GPS is used for the actual M9 measurement, but also for steering and navigating the boat. And moving down here, this black patch is hard to see, but that's where the exosonde is. And then on the bottom here, this is actually the SURF B Nexus data logger. And so with this data logger, you will be able to log and collect all of the exosonde data for you to process later on. So this is the full setup that we used for this measurement. So again, we used the Sontec M9 ADCP here, as well as the exosonde. So the first thing that will stand out to those familiar with ADCP measurements in general is how straight this cross-section or transect appears to be on the map. And so normally the traditional way of using an ADCP to measure on the Mississippi is through a manned boat. So somebody, a person, is physically driving this boat across the cross-section. And it is incredibly challenging to create such a straight line if you're crossing a river, especially of this size. So in general, an ADCP measurement, when you're moving across the water, you don't necessarily need to have a perfectly straight line, but the key here is repeatability. So you are not only looking at one transect, but you need to be averaging multiple transects together in order to get a final discharge value. And so you can remove the uncertainty or variability transect to transect due to the boat just measuring different parts of the water by using something like the SURF B, which has the autonomous feature where you can repeat this transect over and over using the waypoints that you've established at the beginning of the measurement. So this is one aspect that was really helpful for us on a large channel like this to be able to create these transects, transect to transect, that could provide that repeatability. All right, so this is a view from the bank where we started the measurement on. So here's the SURF B, and this is the bank that we are standing on here. And as we moved across the channel, this is about a little past halfway, and I'm sure you can see that the boat is very hard to see. And so it's actually here, circled in the blue circle. And the point of this is that when you're at distances from the boat like this, you can't even see which direction the boat is pointing in order to drive it. And so the auto navigation features here really come into play. They will take control, and you can trust that you're still going in the right direction and you're moving along that transect line that you've programmed ahead of time. And secondly, you also have that live stream camera feed coming in. So when you are approaching that far edge and you can't see it with your naked eye, you can use that camera feed in order to determine if there are obstacles, how close you are from the channel, from the bank, and that sort of thing. So those factors really help out in a situation like this. So let's look at the raw M9 measurement. And so the people who are experienced with M9 using River Surveyor Live will notice that this software that I'm showing the data in is actually RSQ. Now, RSQ is a more modernized software that is meant to pair with the RS5 in particular for data collection. However, you can open M9 files using RSQ as well as S5 files if you have any of those. And then you can take advantage of all the post-processing features in RSQ that may not be available in RSL. So that's just a quick tip for those users. So going back to the actual measurement, so on the top plot here, I'm plotting the boat speed. And so you can see that, as we're moving from one bank to another, we're moving at a steady about 1 meter per second. And then we actually reached the far bank, stopped a bit, and then turned back around. But we cranked up the speed to about 2 meters per second. And I'll explain why in a little bit. But you can see in the contour plot here, basically two somewhat symmetrical looking sections, and one looks slightly different compared to the other. And I will go into details in a little bit here. But first of all, some of the challenges that we faced when we were actually performing this measurement. We mentioned before, but this is a very wide channel. So from the person sitting on the bank to the far bank, it was about 700 meters wide. And so the auto navigation, again, provided this straight ship track, especially when the boat was far away. Another feature that really helped out was GNSS heading. And the reason is this, as you can see, this large vessel coming around the corner here. This is the reason why we actually bumped up that boat speed in the second half of the measurement that you saw. We noticed that as we were coming back, we noticed this large vessel turning the corner, and we needed to get back to avoid a collision. So we had to bump up the boat speed in order to basically race against this cargo vessel. GNSS heading here, in this case on the SURF B boat, provided a non-magnetic heading source. And so what that means is that normally, taking a normal ADCP discharge measurement, most people will use the magnetic compass on board the ADCP. However, when we come into contact with ferrous materials like bridges, rebar, and large vessels like this tends to skew the magnetic compass. And so you will have differences in your angles and your velocities that are a result of the magnetic interference. And so using the GNSS heading is actually a great way to bypass all of those magnetic errors because it's coming from the GPS source instead of a magnetic source. So this was really advantageous for us too, because there's quite a bit of structure in the Mississippi, and as you can see, quite a bit of ship traffic that we were close to as well. Just another safety feature that I think Evan mentioned earlier, features like return to launch, RTL. So basically, if the SURF B has any low battery issues or communications issues, it knows to come back to you or wherever you actually launched the boat. So you can rest assured that you'll always get the boat back if something happens. So going back to the measurement itself, I haven't talked yet about why we have a forward and back transect all in one, sort of stuffed in one measurement here. And the reason is because we actually had a faulty antenna on the M9 system itself. And so mid-channel, we actually lost communications with the M9. But we knew that the M9 had an internal recorder. So all M9 ADCPs come with an internal recorder. And so as long as the M9 is pinging, it won't stop. And so even if we lost communications, we just kept going. So as we lost communications, we went to that far edge here, that far bank. We rested at the edge, the standard number of samples that we knew we should. So that's at least 10 per transect. And then we started coming back. But then at this point, we were a bit interrupted by that cargo ship coming around. And so that's the reason for the kind of double or symmetric looking transect here. And in order to process this data, we were able to take advantage of one of the features in RSQ called subsection. And so what we're able to do with this feature is basically chop up your transect into however many pieces you want. And so in this case, what I wanted to do was take all the data from this point on to the right and basically toss that out, because that was the transect that we were hurrying back. It's of lower quality, and I just wanted to preserve that good transect at the very beginning. And so as you can see here, there are these gray bars or areas. And so that is what I've input into this, this sample dialog here. So I have to tell this dialog at what sample I'm starting the left and the right banks at, and what sample I'm ending those edges at. I also have to input the distance from the right and the left banks. And with those, I'm able to basically subsection this measurement, and the result is this much cleaner looking transect. And so what you can see here in this plot is the color contour of the speed. And so we've reached max speeds at about 0.75 meters per second. Those are red colors that you see here towards the right bank. And let's see, the max, the width or the extent of the measurement was almost 600 meters. And so again, we were from the bank to the other bank, it was about 700 meters total. And then the maximum depth we were able to measure was about 40 meters here with the M9. And the result here, this discharge value from just this single transect was about 6,900 CMS. So that was about 242,000 CFS. And just as a quick sanity check or comparison, the nearest USGS gauge was here at this little pointer here. And this was quite a bit downstream compared to where we actually took the measurement at this star. And pulling up the USGS discharge plot, we were able to see that the discharge measured at the gauge was about 290,000 CFS, so somewhere up here. And our value was somewhere down here at 240 CFS. And there's actually quite a bit going on in between where we measured and the actual gauging station. So that, along with the uncertainty of the actual measurement, you know, we only had one transect this day. This value is well within the range of normal or correct here. So just a quick sanity check. All right, and moving on, we have Sean now who's going to present the water quality mapping with the EXO.
All right, great. Thanks, Shua. As Shua mentioned, I will be covering the water quality portion of our webinar. So first, I just want to take a quick look at the difference between geospatial collection and spot sampling. So, the normal method is to go out on a boat, drop your sonde in the water at specific points, collecting that water quality data. But with geospatial and using something like the SURF B, you're able to collect a much greater area over a shorter period of time. So you're able to see locations that you typically would miss potentially if you were just doing specific areas of spot sampling. So this allows you to track how water quality changes across watersheds, reservoirs, rivers, etc. So because of this overall greater coverage, you're able to identify hotspots faster, trace likely causes, and focus corrective action where it will have the biggest impact. Using a surface vehicle like the SURF B also allows rapid response. And again, you're able to cover such a large area that you normally would miss, allowing you to see what's happening at certain points in the watershed, and then kind of determine where that may be moving and coming from. So YSI provides one of the market-leading multi-parameter water quality sondes in the EXO line. So there are a number of different models and configurations that we can choose from that can fit most, if not all, of your needs. One of the great things with the EXO line is that the sensors are smart sensors, so they're plug and play. There's a large number of parameters available, like dissolved oxygen, temperature, turbidity, and blue-green algae, to name a few. So you can get a bunch of these probes, and depending on the model that you have, you can have either them fully loaded or you can swap them out and continue running your survey. Another great benefit with the EXO is that it has a fast sampling mode, so it can sample as fast as 1 hertz, which is great for something like the SURF B because, when you're moving on a vessel, you want to be able to collect that data as quickly as possible. So having it sample at 1 hertz allows you to really cover and get as many data points over that period of time while you're surveying. So when using the EXO on the SURF B, we use what we call the EXO whale attachment. So this gets added to the platform. So one of the wells in the SURF B vehicle, and the EXO screws into it similar like it would the sonde guard. So what this does is it helps protect the sensors, but it also allows the necessary water flow through the sensors to get your accurate measurements. For logging the data, there are a few options. You may already have an EXO remote handheld, so that is something that you can use with this vehicle. But we also have an option called the SURF B Nexus, which is a data logger. Both of those options will allow GPS tagging of the data, so you're going to know exactly where those points are taken throughout your survey. When using the EXO handheld, one difference is that the data is recorded onto the handheld itself. So the handheld gets the GPS tagging along with the data. So what you'll need to do is when you're done running the survey, you would download it, and that's when you can look at it. But a great feature with the SURF B Nexus is you're actually able to view that data in real time on the SURF B remote. So while you're running your survey, the data is coming in real time, and you're able to actually make quick decisions based off of what you're seeing. So if you see a low DO spot or an algal bloom, you're able to see that happening in real time, and you're able to kind of maybe change your course of action and cover that area a little differently than you would have. And then after you collect that data, there are a few ways to visualize, but one of them is using software such as HYPACK. So the graph you're seeing on the screen here is actually of water quality collected using the EXO and processing in HYPACK to create a nice contour map. Both the Nexus and the remote handhelds, you can export that data and you can quickly import it into HYPACK to be able to create these visualizations. And one other great thing with using the SURF B is that there's repeatability there. So if you're wanting to monitor the same area over and over again to see what is happening over time, you can create that mission and you can actually save the mission and you can continuously reload it back in and run it again. So you're going to be running over the same area over and over, which again, if you're trying to do studies over time, it's perfect because you're able to get that repeatability of the data in the same areas that you want to take the data samples. All right, so running, when we ran the SURF B on the Mississippi, this is kind of the list of equipment that we use. So we use the YSI XO3S sonde, which is the shorty version of our sonde line, which was fitted with a temperature conductivity, PHORP, dissolved oxygen, and turbidity sensor. The data from the XO was logged using the SURF B Nexus, which was installed, on the back of the SURF B with the XO directly connected to it, but also the GPS from the SURF B itself was connected. So again, it allows the data from the XO as well as GPS tagging of that data to be logged simultaneously, where we can then view that in real time. The platform we used was the SURF B FloDuet. As mentioned, it is a dual sensor platform. So again, what's great with this platform is, we're not just collecting the discharge, but while we're doing that, we're able to install the XO3. So we have the Sontec M9 installed for discharge. And then in the other well, we had the XO3 where we were able to collect both discharge and water quality simultaneously. Real quick, just to look at the data that we collected. So looking from right bank to left bank, we were able to quickly plot what was happening with the water quality. The two graphs you're seeing here are temperature and turbidity, because these are the ones where you could see a little bit more happening. But from the data that Jua showed, you could see that the speeds at the edges were a little bit slower. So we kind of expect here, which makes sense, we have a little higher of a temperature. It's also shallower at that point than compared to the center, but we also had kind of some spikes in turbidity compared to the center of the channel. And then just a few other parameters here of what we collected, because again, we had more than just temperature and turbidity that we were measuring. So we also were able to see the specific conductance, the dissolved oxygen percent saturation, and pH. What's great again with the XO is that if there were other interests, so we have the total algae sensor, which is chlorophyll and blue-green algae combined, that sensor could have been added to look at those other parameters. But the primary goal of this survey was for discharge. It was just, we had an added benefit that with this Duet vehicle, we're able to add this XO sonde on as well to collect the additional water quality information. One great feature that Evan had gone over with this, so if you're not doing discharge, but with the Sontec M9, it is a multi-purpose instrument where you can also record bathymetry with it. So if you're performing a bathymetry survey, you're going to have a much larger area that you're going to cover, which would be perfect as well to tie in water quality. So how does water quality complement flow? Flow is figuring out how much water is moving, where it's moving to, how fast it's moving. Water quality is figuring out where quality is changing, where hotspots are forming, and where intervention is most urgent. By combining the two, it helps organizations understand how the water quality conditions change across large water bodies and how conditions move over time. This is going to help with earlier detection, a more targeted response and where that you need to look at, and then the better protection of the environmental quality. And again, by combining the two across water bodies, across the water body of interest, you can gain a dynamic view of changing conditions across the full water body, which is extremely important and compared to just getting single points that you might otherwise miss potential events that are happening. This makes it a lot easier to identify pollution sources, understand how nutrients, contaminants, or low oxygen zones are forming and spreading, and then respond effectively. And lastly, as Evan had mentioned, there are a few new options that are coming out, but one that I am definitely excited about is the winch system. So This is going to be an integrated winch that will go on the SURF B FloDuet system. It will allow vertical profiling of the exoson. So, you know, standard with the exo whale, you're just getting surface water quality, but with the winch system, you're going to now be able to get a complete water column data set. So what's great with it is it has a 100-meter total profile ability, as well as it's already integrated into the SURF B app. So say you're creating your mission plan on it, you can set waypoints within there where the vehicle will drive to that point, stop, do its vertical profile, pull the son back up, and then move on to the next point. So we are hoping to have a release date at some point, but right now it's expected at later this year. So that covers basically my portion of the webinar. So back to you, Jua.
All right, thank you, Sean. All right, so that ends the content portion of our webinar. We were really eager to share with all of you this data set. It is the first autonomous measurement on the Mississippi that we know of. And it's also the widest autonomous gauging that we know of. So it was pretty exciting for us to be on site to perform this measurement, but also really interesting for us to share this with all of you. So thank you again for your attendance. And at this point, we are going to move into some Q&A. And if you've been to some of our webinars before, we like to make quite a bit of time for interactive Q&A. And so if you haven't already, there is a Q&A box, like a chat box in this webinar interface. And if you have any questions, feel free to type them in right now. We have quite a few in already. And so we most likely won't be able to get through all of the questions during this live session today, but you will be receiving a package after this webinar, which will include a transcript of all of the Q&A as well as the answers specifically. So let's get into the Q&A right away. So let's see, there is a question for, let's see, how do you control the profiler on the SURF B vessel? Evan, do you want to answer that?
Yeah, as Sean stated before, the operation of the profiler is actually integrated into the SURF B app. A big part of it for us was to try and make something that was very user-friendly. So it wasn't, you didn't need to have a PhD to operate the profiler or any of the autonomous functions for that matter. So yeah, so you plan the mission, you would normally plan it with a bathymetric survey, and then there are specific features on there that you can create a grid pattern if you're trying to grid out an area, or you can do single spot sampling and drag waypoints out with your finger, or set them with the boat location, and then you can save that mission later on. All the dialogues for specifically for profiling come up and allow you to deploy that the profiler, and that means you can set the depth, you can have it stepping down in small increments, like and set that increment so every 5 meters or every 1 meter if you want, or you can have a very slow continuously sampling down and coming back up again. So there's plenty of options there to suit most or hopefully all of the monitoring requirements.
All right, thanks, Evan. Next question. Do you need a handheld to record the XO measurement? Sean, why don't you answer that one?
Yes, so you're going to need either the XO handheld remote or the SURF B Nexus. The reason is that if you had just the XO that has the batteries, you can internally log the data, but you're not going to get any of the GPS position information. So with the remote handheld, that has a GPS in it so that you're able to log each of the data points with the GPS position. So you know exactly where that data is taken. And then similarly with the SURF B Nexus, it'll do the same thing. I mean, the biggest difference between the two is just With the SURF B Nexus, you'll be able to see that data in real time, where with the remote handheld, it's just recorded internally, and then you can download that data and process in software easily, like HYPACK.
Great, thanks, Sean. Next question. Why does the second part of the transect look so different from the first? And so I'm assuming that's referring to, let me just go back here a couple slides to this. The reason why this part of the transect on the right here, oh, my pointer on here, there we go. On the right here, very different from this side. You'll notice a lot of these little yellow and black dots on top of the data. And those represent warnings. And the warnings that are associated with them are for invalid bottom track. And so when we ramped up the speed here to 2 meters per second, there were some ripples on the surface of the river, and the combination of the fast speed and the water texture basically started bringing the ADCP in and out of the water a little bit. And so you'll see that some of this data, we don't have very, very good data going all the way to the bottom. And that's the ADCP trying to struggle with this very fast moving pace of the boat, as well as kind of bouncing up and down on the surface. And so that's why it looks very different. And that's why I tossed out this coming back portion of the transect. That answers the question. Okay, let's see. There's a question, what is the maximum water flow to maintain the position of the SURF B? Evan, do you want to answer that?
Sorry, what was that again? Oh.
What is the maximum water flow to maintain the position of the SURF B?
Okay, yeah. So we have on the Seeker models and the Duet, the max speed is 4 meters a second, but that which is quite fast, and that's some really quick water. The fastest autonomous transect I've seen done is at 3.5 meters a second in New Zealand. They weren't driving it, so with a little bit of speed overhead, you know the fastest flow would be approaching 4 meters a second. But as we know, it can be faster in the middle and slower on the outsides. So yeah, you will be around that 4 meters a second for water speed in flow. You do need a little bit of speed overhead for the boat to be able to navigate in a perfect straight line. So it'll be approaching that 4 meters a second mark.
Thank you. Next question. You mentioned the fast logging option for the EXO. How do the sensors themselves perform in terms of adjusting and re-equilibrating their measurements quickly when moving quickly through changing concentrations or water environments? Sean, would you like to take that one?
Yeah, so each of the sensors has their own response time, so you would need to look at what the response time is of each. I think the DO sensor has probably the slightly longer one because of the foil membrane and the time it needs to come to equilibrium. However, when you're on a moving vessel, so the faster you go, there is going to be some potential lag as far as where the data is taken and that response time. So that needs to be taken into account when you are processing the data to understand exactly where that data is being taken. If you're going through large changes, and this is where I would say the Nexus will come in play and be huge, is that you're able to see these changes happening. So if you continue moving through, you might not get that absolute value, but what you're able to do is see that those conditions are changing. But with the Nexus, again, seeing it in real time, you can stop the vehicle and you can collect that data in that fixed position for a bit longer so that you can come to equilibrium and ensure that, you know, the sensor stabilizes before moving on. But one big thing, you know, when collecting geospatial water quality, you know, and using a vehicle, it all does come down to how fast you're going with the vessel. You know, typical speeds, say, you know, one meter per second when you're doing, say, bathymetry and water quality. The slower you go, the more time you're going to allow it to stabilize. But unless you do kind of park at points for a bit, you know, there'll always be a little bit of time lag, but that's something that you can take into account when you post-process.
Next question. Could you talk more about stationary boat measurements in moving bed conditions? That's an interesting question that we did not touch on this webinar. Generally speaking, in moving bed conditions, many people will default to stationary as opposed to moving boat. And that is definitely an option. So stationary assumes, as the name implies, that you're actually stationary and just taking station by station, kind of like a flow tracker, measuring those velocities and averaging those at each station. So that is a method that you can use, especially on these larger rivers with higher flows, where you will likely have moving bed. With moving bed, you obviously don't want to be using bottom track, at least the raw values. You'll have a choice of either correcting the bottom track measurements if you do use bottom track for a ship track, or using stationary, or using GPS or GNSS for your ship track. So the nice thing about the SURF B app is that you can toggle back and forth between moving boat and stationary methods. And so for those waypoints that you've set for your left and right banks in moving boat, once you toggle over to stationary, you actually keep those points on the app, and then the stationary portion of the app will populate any number of stations that you want in between. And so you will still maintain that same cross section, but you can change over to stationary method if you prefer. The other option, as I mentioned, is to use GNSS as your ship track reference. And if you really want to get technical with it, you can also use GNSS heading if you're using an RS5 for your ship track, for your heading as well. So you can bypass any of the normal interferences that you'll see with either moving bed conditions or magnetic interference that way. Let's see, there were a couple questions involving integration with HYPACK. Can you input a MavLink line plan into the SURF B boat to control a mission that way? Evan, would you like to answer that?
Yeah. So we have a generic MavLink waypoint import function on our SURF B app. So you can run a mission that is generated in HYPACK and outputted as a MavLink waypoint mission. They have that feature on the HYPACK. So we have had a few customers using that function at this stage. Yeah.
Next.
There's also another question there, just quickly, briefly, on the SURF B batteries. There is one there from Christoph Sauter about battery size. The 15 amp hour batteries will not fit. The maximum capacity of the SURF B is 12 amp hours or less. So we usually say between 6, 9 or 12 amp hour batteries, and it takes 2 batteries of the same capacity. Yeah.
Next question. How deep in the water were the exosondes? Is there any interference with sunlight and exo readings for parameters that depend on light measurements like chlorophyll A? Sean, you want to answer that one?
Yeah, so they're probably, I would guess, about 6, 8 inches in the water column, and basically what they are, it's screwed into the exo whale. So the exo whale does block out, so there's not going to be any sunlight or interference. It's similar to how it would be installed in the guard itself. So the exo guard that you're actually seeing in the picture right now, That kind of helps with any interference and optimizes the sensors that require, that point where they need to measure, like turbidity, chlorophyll. So yeah, when it is installed in the EXO whale attachment, it is shaded. It's not going to have any interference, and the way that it's built is it helps kind of break up the disturbance so that there's not an influence of bubbles that gets trapped over the sensor face. So yes, I think that should cover that.
Right. And I think we have time for one more question. It was asked, I think, a couple times here. What happens when the connection is lost to the SURF B boat or vehicle? Evan, do you want to cover that one?
Yeah. Briefly, so where you arm the boat, so there's an arming feature on there, so that you can have it armed and disarmed state, so it makes it easy and safe to carry in a disarmed state, but the boat can be turned on. Where you arm the vessel is the location of where the vessel will return to on either a on low battery alarm that comes off or loss of comms between the boat and the transmitter. It will, if it loses comms for 10 seconds, it'll automatically turn around and come back to that launch location. So there's sort of it's low battery or loss of comms, and it'll, what they call RTL, return to launch, and that launch location is set where you arm the vessel.
Great, thank you. I said that was the final question, but we actually got a fun question to round it out here. Where are we going to gauge next? That's a great question for maybe the audience to chime in. Where would you like to see the next gauging? Any interesting sites or particular measurements that you'd like to see being run on the SURF B using the M9, using the RS5, EXO, what have you. So let us know. Thank you again for your participation in this webinar. And as usual, as I mentioned before, we will be sending out a sort of care package with the copy of this actual presentation, along with Q&A and some other relevant information and material. And with that, if you have any further questions or concerns, feel free to contact us at sontech@xylem.com or contact your local representative. And we look forward to seeing you soon. Thank you. Bye-bye.